This lesson is about how you will determine the limiting reactant and the access reactant. You're going to be utilize the concept of mole and the mole ratio in order for you to figure out how many moles of the product and how many mole of reactants are formed and used in the chemical reactions. I'm just gonna go ahead and start by giving you an example of what the question would be. So instead of doing question number 1, I'm gonna go ahead and show you question number 4A first. So first you're gonna have to balance chemical equation. If the chemical equation is not balanced, or unless attempt to double check the chemical equation to see if they balance out. This is going to be one-step process. So I'm starting out by having FeS2 react with oxygen gas, and that give you the product of Fe3 plus this. So basically what this equation is telling you is that we have an iron sulfide reacts with oxygen gas, and that yield or give the product of iron oxide and sulfur dioxide. So basically this is molecule, this is ionic compound, this is ionic compound, and that is a covalent compound. That's how I name them a little bit different. So we're gonna go ahead and start with balancing equations. So for this one, I'm just gonna go ahead and pretend like the chemical equation is already balanced out. So you're gonna be utilizing the coefficient, which is 4, 11, 2, and 8. In dealing with how to convert moles to mole using mole ratio. So first we're going to have to determine limiting and access reactants. So basically these are reactants and these are product. So please do understand, whatever the chemical, which is ionic compound, molecules, are on the left-hand side are the reactants, and this means chemical reaction proceeds, and when the reaction completes, and give you these two products. So basically, we're gonna have to go ahead and interpret what this equation is telling you right now. So this one means that 4 mole of iron sulfide reacts with how many mole? 11 mole of oxygen gas. And it gives you a product of 2 mole of iron oxide and 8 mole of sulfur dioxide. Then, when you look at the question, there are 2 different ways for you to do it. So this one, make sure you keep this in mind. This is mole to mole, which is much easier than grams to gram, which is going to be on my second video. This is mole-to-mole project. Go ahead. I'm just going to mole-to-mole project. It's very easy. So first, you're going to have to look at the 2 different reactants, right? And read the question. So when 26.62 mole of FeS2. As you can see, I'm actually writing down what is given. So I'm doing 2 different ones just to see which one will be my limiting reactant. Moles of oxygens. You're gonna have to understand and do some refreshment over here. So the limiting reactants will run out first. Access will be left after reactions complete. And we're gonna have to figure out how much of this being used by calculating how many mole used. We can figure out how many moles are left. Once you get the mole concept, you can figure out how many grams of that are left in the chemical reaction as well. So we come back to the starting material, which is the reactants. We have a certain number of moles right here. So first, as you can see, that we have mole of iron sulfide. Then the mole of oxygen gas. But we don't know which one is the living reactant unless we are actually using the coefficient into considerations. So I'm gonna write that down, 1 mole of this. At the bottom you write mole. Spell FeS2. That's the first step you need to do. So in order for us to get this number, we're going to go ahead and look back at the chemical equation, which is for number of mole. So I'll simplify that one. So you will have this multiplied by 1 divided by 4. Or you can simplify this one by doing this. And that should give me those numbers. And you do the same thing here. You write down 1 mole of oxygen, mole of oxygen. But we're gonna go ahead and look at how many mole of oxygen are being used in a chemical reaction, which is 11. You can tell that by using coefficient. So coefficient is very important. So go ahead and do the math now. I simplify this number for you. 1 divided by 11. Do the fraction first and I'll give you number of mole. So this is the very first thing you need to do. So I'm going to go ahead and get my calculator. .62 divided by 4, and that should give me 6.65 mole. And I do the same thing, which is 5.44 divided by 11, and that should give me moles of oxygen gas. So now once you get the number for the first step, you will figure out by using this definition, which is the limiting reactant and the excess reactant. So the smallest number of mole will be your limiting. That's like rule. This is becoming accessed. Make sure you box this access so do you know, oh, this is limiting, this is access. So this is very important. So when we talk about or when we refer to limiting or access, you would go back to this calculation that you have. So from now, we actually be able to answer the question 2 right now, because what the question is, what is the limiting reactant? Which is, you tell me what it is now that you know how to do it. So now I'm gonna go back to question 4a, which is how many mole of SO2 are formed. So basically with this one, I'm just going to show you how to do A. We will always start with the limiting one, which is the smallest number of mole. Which is this one. Okay, we start out with the limiting mole. And at the bottom, we're gonna write down moles of oxygen. So basically what goes here is a limiting mole. And you're looking for how many moles of sulfur dioxide. So now we go back to your coefficient. Right here, it's 11, 4. So now you do the math, which is 0.495 times 4 divided by 11. Divided by 11 times. Basically, either way you get the same answer, which is this one. Form. So now we go back to question C. We figure out how many moles are left over at the end of the chemical reaction. We always start with the limiting mole, which is the same thing. So we're looking for the excess one. So we go back to this one. Iron sulfide is your excess. You write down mole. Your limiting mole should be at the bottom. So then you go back to your coefficient. Oxygen is 11. This is 4. Then you get the answer. Which is 0.18 mole used in the chemical reaction. But then when you go over here, in order for you to calculate how many moles are left after chemical reaction, you're gonna have to figure out how many moles are being used, which is this one. So you go back to your starting material, which is 26.62 minus 0.18, and that should give you the number of moles. Which is this one.